Welcome, students. Today we are diving into our Grade 8 Algebra I explainer titled Rearrange Formulas and Solve Literal Equations. I know, the term literal equations might sound a bit formal, right? But honestly, the secret here is super simple. We're going to rearrange these formulas using the exact same rules of equality you already use for everyday numbers. Let's get right into it.
Okay, here's our quick roadmap for today. First, the target. Then, solving area for width. Third, solving distance for time. Fourth, correcting common formula mistakes, and we'll wrap things up with a recap and transfer.
So, part 1, the target.
What are we actually trying to accomplish here? Well, by the end of this explainer, you're going to be able to isolate a chosen variable while completely preserving equality. You'll do this by spotting the operations applied to both sides of the equal sign. And finally, you'll verify your solution by substitution. Really, this right here is the absolute gold standard for algebraic thinking.
Moving on to part 2, solving area for widths.
Let's look at this classic formula for the area of a rectangle. We've got capital A for area, which equals L, the length, times W, the width. Now, as it's written right here, it's perfectly set up to find the area. But what if we already know the area and the length, and we actually want to find the width? Well, we need to rearrange it.
Here is exactly how we do that. To solve for our target variable, W, we look at that right side of the equation and ask, what's happening to it? Well, it's being multiplied by L. To undo that, we just apply the inverse operation. The inverse of multiplication is division, right? So using the division property of equality, we divide both sides by L. By doing it to both sides, we preserve equality, and that leaves us with our brand new rearranged formula. A divided by L equals W.
Now, what's genuinely cool here is that we can prove these algebraic steps actually work by substituting in some real numbers. Let's pretend our area is 12, our length is 4, and the width is 3. In the original formula, 12 equals 4 times 3. Yep, that's true. Now check out our rearranged formula. Width equals area divided by length. Plug the numbers in. 3 equals 12 divided by 4. That is also perfectly true. The balance, the equality, is totally preserved. All right, it is time for a quick pause check. Take a second and think about this. What specific property of equality did we just use to isolate W in that formula? A equals LW.
Did you say the division property of equality? Because if you did, you hit the nail on the head. Since we used the inverse operation of division on both sides of that equal sign, we successfully preserved the balance. Awesome job.
Let's keep rolling. Part 3, solving distance for time.
Now, here's a formula you are going to see all the time in both math and science. Lowercase d stands for distance, r is the rate of speed, and t is time. Right now, it's solved for distance. But say we're planning a road trip and we want to know how long it's going to take. That means we need to solve this formula for t, the time.
Just like we did before, we zero in on our target variable, t. We can see t is being multiplied by r. So we apply our inverse operation, which is division, and use that division property of equality to divide both sides by the rate, r. Boom! This gives us our rearranged formula, d divided by r equals t. Notice how treating these letters just like normal numbers keeps our variables and their real-world units completely clear. But there is a massive condition here. You have got to note that r cannot equal 0.
And again, we've got to verify our work by substitution. Imagine you travel 100 miles at a steady rate of 50 miles per hour. In our original formula, 100 equals 50 times 2. In our new formula, your time, t, is distance divided by rate. So 2 equals 100 divided by 50. It works flawlessly. Our rearranged equation perfectly preserves equality.
Okay, part 4, correcting common formula mistakes.
Let's talk about the pitfalls, because this is where a lot of people trip up. The single most frequent mistake? Changing only one side of the equation. If you divide the right side by a variable, but you just forget to divide the left side, you have completely wrecked the equality. You literally have to treat the equal sign like a perfectly balanced scale. Whatever you mathematically do to one side, you have got to do to the other.
Here's another really common error, just dropping a factor. Honestly, sometimes you might see the L in A equals WL and be tempted to just erase it to leave W by itself. No way! Never just drop a factor. Inverse operations are all about mathematically canceling values by turning them into a 1 or a 0. We don't just erase them from existence.
And this brings up a subtle but absolutely crucial rule.
When you divide by a variable, like r, you must explicitly note that r is not equal to 0. Dividing by a variable without noting this non-zero condition is a huge error, because it can actually break the fundamental laws of mathematics. Which brings us to pause check number 2. Think carefully about what we just covered. In the formula d equals rt, why must we explicitly state that the rate, r, is not equal to 0 when we solve for time?
Well, the core reason is that division by 0 is mathematically undefined. You simply cannot divide by a variable unless you can guarantee it represents a non-zero number. Plus, think about it logically. If your rate of speed is 0, you literally aren't moving, which makes calculating travel time completely impossible anyway.
Let's bring it all home. Part 5. Recap and transfer.
Everything we are doing today directly applies mathematical practice 7, look for and make use of structure. By recognizing that these literal equations follow the exact same structural rules as basic, everyday arithmetic, you start making sense of algebraic structure. You are literally just treating unknown variables like normal numbers.
So here is your strict 3-sentence recap to lock all this in. First, isolate a chosen variable by using its inverse operation. Second, preserve equality by applying that exact operation to both sides of the equation. And third, always verify your new formula by substitution. And definitely note those non-zero conditions when dividing by a variable.
I'm going to leave you with a final thought and a transfer challenge. Take a look at the formula for the area of a trapezoid. Area equals base 1 plus base 2 divided by 2, all multiplied by the height, h. Now, using the equality rules we learned today, how would you unpack this slightly larger formula and isolate h?
The structure is exactly the same. You're just going to have a few more inverse operations to perform. So grab a pencil and see if you can tackle that trapezoid formula all on your own. Keep preserving equality. Thanks so much for joining me for this explainer. And just ponder this. If we can use these simple rules of balance to unpack the geometry of a trapezoid, what other complex mysteries of the universe could we unravel just by rearranging the pieces?